Hello there, geometry geniuses. Today we're doing today we're going to be doing some volume of composite figures. So we've done area with some odd shaped um, polygons. Now we're going to do volume with some odd shaped prisms. So here we have three different composite figures. Now a composite figure composition means a combination of things of different shapes. So the first one almost looks like a U shape. You got a couple of blocks. The second one looks like a ramp on top of a block, and the third one looks like a ramp. So what I want you to do is find the volume of each of those objects. So in order to do that, you're going to have to figure out um, the volume of each of the different sections and then add the total volumes together. Now, if you need the video, then keep watching and we'll go through it. If you think you can do it on your own, then pause the video, go do your calculations, and then you can just come back or use the answer key to check it. If you don't want to watch the video, the answer key is in Teams. Feel free to go look at the answer key and making sure that you're doing all the calculations correctly. That'll save you time from having to sit here and listen to me babble on. But whatever you decide to do, just make sure you're checking your answers and doing everything correctly. So when you're breaking these three-dimensional object up into smaller parts, make sure they're smaller parts that are manageable for you. Each person might view it a little bit differently as to which parts we should use. Some of them are a little more obvious than others. For example, for this first one, figure number one, looks like two cubes in a rectangular prism. So find the volume of those three sections. You got a cube, and your rectangular prism at the bottom. Just find the volume of those three things, add them together, and you're all set. For the second figure, there we go. Again, we have a cube, rectangular prism at the bottom, and then we'll have a triangular prism. So for the volume of each one of these shapes, it's the area of the base shape times the height. So for the triangular portion, you would do the area of the triangle and then multiply it by how thick it is, which is technically the height. The distance between the two bases is considered the height. And for our third figure, you'll probably do the rectangular solid and then the triangular prism. So I guess you might be waiting for me to start, so I'm going to get going. So volume, length times width times height. I can figure out the width by 5 feet. The height is from the 5 feet over here. And then along the bottom, I got 5 feet, 5 feet, total length of 15 feet, which means it's also 5 feet in between. That's how I know 5, 5, 5, 5, 5's all around for both of them. And then our rectangular pyramid prism at the bottom has a height of 5 because it's a full height of 10. The height of each cube is 5, so 10 minus 5 is 5 left. 5 by 5 by 15. So you multiply 5 times 15, and then you add them all up. So if you're just checking, there you go. If you're doing it, you might need to pause it because I am moving on, moving on, moving on. Okay, so I already identified the three shapes that I'm using. So I'm going to do the cube, I'm going to do the triangular prism, and I'm going to do the rectangular prism. When we get to trying to figure out the height, how do I know for sure it's a cube? Well, I guess I don't yet. Or you don't yet, I do. I know that a full height of 10 feet was given. There's 5 feet here. So that means the rectangular prism at the bottom has a height of 5. That means this one has to be 5 as well. 5 by 5 by 5. So I guess I do know all these are 5. All right, our triangular prism. We need the area of the triangle. In order to do area of the triangle, it's base times height divided by 2. So our base was the full length of 17 minus the length of the cube here, that was 5, leaving me with a base of the triangle that's 12. The height of the triangle matches the height of the cube, the edge of the cube, so that's 5. Do Pythagorean theorem, and I can get the area of the base of the triangular prism portion. and then I do, for volume, it's area of the base times the height. So the area of the base is the 30 from the area of the triangle. And the height is technically considered like the thickness, the distance between the two triangular bases, which is 5. And then the third portion is just that rectangular prism at the bottom, and then we add them all up. Good to go. So here we go. All right, so the rectangular prism, length times width times height. Our base is 12.5 feet by 11 feet, and height is 5 feet. It doesn't really matter which one you view as the base, the width, and the height, because you're just multiplying 3 numbers together. For our triangular pyramid prism portion, I need to get the area of the triangle. So it's going to be base of 12, height of 5 again, base times height divided by 2, 1/2 BH for area of a triangle. Once I have the area of the triangle, I will multiply it times 11, because 11 is the distance in between the two triangles. That's what the height is considered, the distance in between the two triangles. So our triangular base, the area of the triangle is base times height divided by 2. That's what the capital B stands for in our volume formula, the area of the base shape. So the area of our triangle, base times height divided by 2, is 30, times the distance in between the two bases, which is considered the height of the prism. And then we add them together. So those are pretty straightforward, quick and easy. So let's try this one. Find the volume of the following composite shapes. So looks like a house. So I did the top triangular prism separate from the rectangular prism at the bottom. So why don't you find the area of those two, or sorry, the volume of those two shapes, add them together. We'll see if we get the same thing. Pause it, try it, come back, and we'll check it. So in order to get the volume of our triangular prism, the top, we need to get the area of the triangle, and then we'll multiply it times 5, because that would be considered the height. The distance in between the two parallel equal bases would be the height of our prism. So I need the area of this triangle. Now, we were given the height of 4, and the base down here of 8 centimeters would match the base up there for our triangle. So that gets us our area for our triangle. The area of the triangle base is base times height divided by 2, or 8 times 4 divided by 2. So now we can find the volume of that section, because volume is simply the area of the base times the height. So I took the area of the triangle, boop, and times the height. Again, the height is the distance in between the two equal parallel bases, so that's why it's 5. As far as the bottom portion, the one that I outlined in red, that's just 6 times 8 times 5. And then, of course, you add them together, and you got your volume. All right, so let's try the next one. It says the following bench is made of solid pine. Pine has a density of 23 pounds per cubic foot. How much does this bench weigh? In other words, find its mass. Well, I know that the volume of a cylinder, volume of any prism, is area of the base times the height. So the area of our base will be the area of 3/4 of our circle, because we're going to have 3/4 of a cylinder. Notice that the radius is given in inches, but the full length is given in feet. So we have to convert everything. So I want to pay close attention to my radius down here. So my radius is 18 inches, and it's 12 inches per foot. So I'm going to convert it into feet. Now, how do I know to get it into feet versus getting it into inches? Well, up here, our density calculation was pounds per cubic foot. So I need everything in feet before I do any of my other calculations. Now that I know how many feet the radius are, 1.5 foot for the radius, now I can find the area of the 3/4 of a circle, then times it by 12 to get me 3/4 of a cylinder. So the volume of our bench is 3/4 of area of the base times height. So our area of the base is pi times 1.5 squared. That gives me 20.25 pi. Now I'm going to leave this in terms of pi for now, and then I'll round my answer later. Now that we know the volume, we're going to use our density formula because density equals mass divided by volume. The density of pine is 23 pounds per cubic foot. So I'm going to use that as my density. And I'm going to use my 20.25 pi for my volume. Then I'm going to cross multiply. So ultimately, I'm doing 23 times 20.25 pi. So I can either leave it in terms of pi, the directions didn't say either way, or I could carry 4 decimal places. Honestly, what you should do if it doesn't tell you and you have pi involved, just leave it in terms of pi. But either answer would be acceptable as long as you kept 4 decimal places accurately. All right, so we did 3/4 of the cylinder after a nice little conversion of inches into feet. Now, little Johnny dropped a snow cone. Let's see how many cubic centimeters of shaved ice he's dropped onto the ground. So little Jimmy drops a snow cone. Let's figure out the volume. So we have a cone on top of a sphere, a cone on top of half a sphere, actually. So our cone is 1/3 area of the base times the height, and our sphere would be 4/3 pi r cubed, and then divide it by 2 because it's only half a sphere. So our units are all in centimeters, so no conversions needed there. The volume of the cone is 1/3 of its cylinder counterpart, so 1/3 of pi r squared times the height. Again, we can leave our answer in terms of pi, works out pretty neatly. If you calculated the decimal, it'd be 301.5929 would be the correct rounded decimal place, 4th decimal place, 301.5929. And there's question number 6. Pretty straightforward, pretty easy. So now you're going to go do the problem set. Go try some of these on your own, and then I will talk to you and see you soon. Nice and short and sweet. Some easy calculations. Hopefully I didn't go too fast. Now go try some on your own. Check the answer keys and make sure you're doing them correctly. All right. Take care, be safe, and goodbye.